Poets and lovers have, since time immemorial, romanticized this particular human sense organ. The eyes are perhaps the most important communicator of our feelings. As they say, the eyes do not lie. But eyes have a more basic function to perform, that of vision. The eye is, first of all, a wonderful, complex organ which helps us to learn about the world around us. Without being aware of the process, we can perceive many things about the object we are looking at. Its size and color, its texture, its dimension, and its distance from us. The eye consists of many parts which must work together to enable us to see.
If you see the structure of the eye, what we usually see is the eye covering by the upper lid and the lower lid, and just the black portion of the eye, which is called cornea, and the white portion of the eye, which is called sclera. Actually, there is much more to it inside if we have a look at it. Usually the eye has the outer covering, which is called cornea. This portion is called the iris, which is a pigmented layer and gives the color to the eye. Right in the center there is actually a hole which appears like a black dot in our eye. This black dot is connected to these ciliary muscles here, which are responsible to make the pupil contract or dilate. If you are in a dim light or in a dark room, you will always find the pupil expands and admits as much light as it could, so that slowly the objects are seen by us. If we are in a glary atmosphere or a sunny day, if you move out of the house, you will find your pupil contracts and admits minimum light, which is very easily focusing the images on the retina. Now, just behind the iris here, if I open the eye, there is a crystalline lens, which is a jelly-like substance, which admits the rays of light to focus it on the retina here at the back portion. Because of this lens here, the eye cavity is divided into two portions. The front portion is called anterior chamber, which is filled with aqueous jelly, and behind the lens there is the posterior chamber, again filled with a jelly called vitreous. Both these jellies are transparent and admit the rays of light to form the image on the retina. This lens also is attached to the ciliary body here, where to focus the object for the near and far, the lens focus also is altered due to these ciliary bodies. When the eye tries to see the distant object, the focus of the lens is made thinner and the focus is adjusted to form the object, image of the object on the retina. When we see the near objects, this particular crystalline lens goes more thicker due to the action of these ciliary bodies here, and the image is formed again on the retina to see the near objects clearly. This is so involuntary action of the eye that you hardly realize that you are focusing your eyes at the distance and at a near vision simultaneously without giving any strain to the eye. If we go little back here, you can see three tunics. One is white, which is called the sclera of the eye. This is a tough coating which protects the eye. The middle portion here, you can see it in red. It is full of blood vessels which is responsible to give the nutrition to the eye. The innermost layer is called retina, which consists of photosensitive cells which sends the electric impulses to the brain via this optic nerve. Here you can see the arteries and veins also going through this optic nerve. If I close the eye, this is the thick nerve which is connected to the brain, and in the brain there is a visual cortex where the image is formed and we see the objects very clearly.
The eye is often compared to a camera. In fact, the camera is perhaps the only machine directly modeled on a sense organ. However, the eye differs from the camera in one respect. The eye takes two simultaneous pictures, one in black and white and one in color. To see colors, we have special cells in the retina called cones. The other cells, called rods, register only black and white.
Once we understand the structure of the eye, it is very easy to see that the common vision conditions like long-sightedness or short-sightedness are not really the diseases. They are the result of the shape of the eye.
In the normal eye, the cornea and the lens refract or bend light directly on the retina. Thus, we get a crisp and clear image. If the eye does not refract light correctly, the image we see is blurred. This is called refractive error. There are 4 types of common refractive errors: hyperopia, myopia, astigmatism, and presbyopia.
Hyperopia is the condition which is also known as the long-sightedness. In this, actually the patients see the near objects very, very blurred. This condition occurs because the distance between the cornea and the retina is very short. So the image which is formed is behind the retina, and to bring the image on the retina, you require the plus correction. These children or the hyperopic children have the very, very strong accommodation. Now, what is accommodation? If you go back to the structure of the eye, you see the cornea has a crystalline lens behind it, which is attached by the ciliary muscles. These ciliary muscles have the capacity to make the crystalline lens thin and thick, as we are seeing the distance object and the near object. In short, when you are looking at the distance object, the crystalline lens is made thin by the ciliary muscles, and we see the very clear object image on the retina. Whereas when we look at the near vision or the near objects, the crystalline lens is made thick by these ciliary muscles and the clear image is formed on the retina. This is called the accommodation of the eye, and this accommodation actually happens without our knowledge. It is very automatic. When the eye sees the distance objects, it is focused by the thinner lens, and when we see the near objects, the crystalline lens becomes very thick and the image is formed again, which is very, very clear on the retina. These children have this strong accommodation which can tax them at the end of the day. Like if they come to the clinic, we ask them to see the distance chart, they can read it very clearly, but this is due to the strong accommodation they are using for the distance. This accommodation is supposed to be seen for the near, and this taxing can make the child squint because between the two eyes there is always a dominant eye. The dominant eye takes the full load of the seeing mechanism, and the other eye, which is called recessive eye, goes diverting. and that's how the squint sets in.
In myopia, conditions reverse. Distant or faraway objects seem blurred, but nearby objects are seen clearly. Myopia occurs when the eyeball is long from front to back. Therefore, only the images of nearby objects focus on the retina. Images of distant objects get focused in front of the retina, thus creating a blurred picture. Sometimes the cornea is too curved, and this too causes myopia. Myopia is discovered in children aged 8 to 12. But because the eye continues to grow throughout the teenage years, myopic conditions may become more severe. These vision conditions can be easily detected in children if parents and teachers are observant and look out for the following symptoms: poor school results, lack of coordination, poor sports performance, headaches and tiredness, red or teary eyes. In case of myopia, the child will be found squinting or frowning when looking at the blackboard. He will be seen copying from a friend's notebook instead of copying from the blackboard. In case of hyperopia, the child will display lack of interest in close work, such as reading or drawing, and will be seen squinting at a book while reading. Both these conditions can be corrected either by wearing glasses or contact lenses. To correct long-sightedness or hyperopia, convex lenses are used to bend light rays more sharply. To correct nearsightedness or myopia, concave lenses are prescribed. A concave lens spreads light rays so that the image focuses on the retina. Refractive surgery is another method of correction.
Presbyopia is another vision condition which is very commonly seen after the age of 40. Here, the patient has a difficulty in seeing the near objects. They have the difficulty in threading the needle or reading the newspaper. This condition usually occurs by the age of 40. As the patient grows older, the correction also grows higher. This condition, majority of the times, is mixed with the hyperopic correction, because hyperopia also needs the plus correction and presbyopia also needs the plus correction. But in hyperopic condition, actually the shape of the eye or the distance between the cornea and the retina is short. And in presbyopia, the accommodation itself is affected. That is, the ciliary muscles lose the capacity of contracting and expanding. Here, the patients need only the plus correction for seeing the near objects. This condition also can occur in myopic patients, in hypermetropic patients, and as well as the people who don't need the spectacles previously do need the spectacles after the age of 40.
Some people are astigmatic. It means blurred vision at all distances. It is neither long-sightedness nor nearsightedness. But one can have astigmatism in combination with myopia or hyperopia. For the eye to function normally, the cornea must have the same degree of curvature in all directions. If the shape of the cornea is slightly distorted and has different degrees of curvature, light does not get focused properly on the retina. This causes blurred vision. For correction of astigmatism, there are three options: glasses, contact lenses, and refractive surgery.
Causes of astigmatism are not really well understood. Some researchers believe that it is heredity. Some believe that it is the way the eye develops in the mother's womb. Now, it is a well-established fact that all these vision conditions are not diseases but can be detected earlier and corrected earlier to avoid the further damage.
Our eyes are precious. Let's take good care of them.